This video introduces the main features of electromagnetic field simulation software called InventSim. The software is being actively developed since its inception in 2006 by a Polish high-technology company Invent. The solver implemented in InventSim is a general 3D finite element package for solving closed or open domain electromagnetic problems. It is a tool for the analysis of microwave circuits, like junctions, filters, couplers, multiplexers, or antennas. To ensure the high quality of the solution, we use higher-order basis functions that improve the accuracy of field approximation. All curved surfaces defined in a given project are accurately represented by curvilinear tetrahedral elements. By comparing them with linear elements, it allows us to accurately represent curved surfaces with lower mesh resolution. InventSim allows a designer to incorporate various boundary conditions, including lossy conductors defined as impedance boundary conditions, absorbing boundaries to simulate open structures, or symmetry planes applying perfect H boundaries. Another type of boundary condition allows the inclusion of lumped RLC elements in an EM simulation. InventSim allows one to define lossy dielectric, gyromagnetic, or dielectric material with frequency dependence according to the Debye model. For high-frequency and terahertz applications, we can also consider conductors as bulk, penetrable by the electromagnetic wave, frequency-dependent material. The designers often want to use electromagnetic simulation results in circuit simulations. InventSim makes those two worlds compatible with lumped ports that are normalized 50-ohm reference impedance. Such ports use simple voltage and current relation to evaluate the transfer function, and results can be imported to circuit simulators. Another feature is the possibility to define lumped RLC elements as 2D rectangular objects, similar to SMD lumped elements. One can select to use either series or parallel RLC circuit, define its terminals, and provide values of the lumped elements. It is easy to construct 3D models and set up a simulation with top-of-the-art, user-friendly interface, easily parameterized design with variables, equations, and use custom, hierarchical coordinate systems. The variables can be defined on the fly. Use Boolean operations to construct complex objects starting from 1D, 2D, and 3D primitivities. One can also import and export models in step file format to interchange them with other software. To adapt your design to the additive manufacturing process, we prepared a module enabling free shape deformation. For an arbitrary 3D object, one can define the deformation field, which can move, squeeze or stretch selected parts of the object, yielding additional degrees of freedom to improve a given design. The deformation can be parameterized, and its parameters can be tuned or optimized. It can result in a smooth surface profile of the final shape. The resulting geometry can be exported to an STL file and processed further to prepare the input files for the 3D printing machine. A unique feature of InventSim is the interactive design tuning module. In this mode, InventSim creates a multivariate model of the designed component's response versus design parameters. It can be created for an arbitrary number of design variables in a period comparable to the time of a single simulation. The designer, by simply moving sliders, can see the prediction of the device's response when changing the design variables. The prediction is updated on the fly. Afterward, one can verify the prediction by performing a simulation and iteratively repeat the process. This gives the designer a robust tool for manual design tuning. InventSim assists the engineer in filter design. Built-in module for coupling matrix synthesis makes it possible to design a generalized Kapy-Sheff response prototype filters with few clicks simply by specifying passband, filter order, and requested return loss level. Optionally add real or complex transmission zeros. The filter response is instantly updated. One can also define the resonator quality factor to observe predicted insertion losses. Next, Specify desired coupling scheme. One can use the editor to arrange the resonators and define the coupling scheme. Finally, synthesize the coupling matrix and use it in a given design. We, at Invent, put a lot of effort into creating a tool not only for electromagnetic field simulation but, more importantly, for full-wave design optimization. We provide two types of optimizers. The first is a standard gradient-based, where the goal is defined by specifying allowed and prohibited regions of the transfer function. The second one is designed to optimize microwave filters with a generalized Kapyshev response, is using zero-pole methods developed by our team that give remarkable efficiency. With this, one can optimize filters with complex transmission zeros to shape given grouped delay response. Define as many optimization variables as needed, as the optimization speed is not significantly affected by the number of design parameters. Mesh generation can be time-consuming, especially when adaptive mesh refinements are involved. In design optimization, it is executed several times, which lengthens the design process. InventSim reduces the impact of mesh generation by applying mesh deformation. When enabled, the mesh is deformed along with the geometry changes made in the model. It gives several advantages in design efficiency, allowing to reuse of results of previous simulations at the solution phase. When designing open electromagnetic structures and antennas, it is crucial to predict the far-field radiation of the device. InventSim implements the absorbing boundary condition and near-to-far field transformation, which allows evaluating the fields in far field based on near-field solutions computed on absorbing boundary condition surfaces. The far field is computed in an additional post-processing step. Also, the radiation efficiency and radiated power are solved. The radiation pattern can be displayed either on a 2D plot, polar or linear, or a 3D plot. The advantages of InventSim in the design process are not limited to the high efficiency and accuracy of the solver and optimizer. InventSim is very competitively priced and licensing is flexible. You can save a lot of your time and money. Just contact us and evaluate the software.